Welcome to the Rotary Parallel Multi-Axis CAM Strategy lecture by Todd Frazee of Sierra College. In this lesson, we'll dive into the Rotary Parallel CAM strategy in Fusion, a versatile tool used for machining cylindrical parts with precision. The Rotary Parallel strategy generates toolpaths that follow the surface of the workpiece as it rotates, creating smooth, parallel cuts, ideal for finishing operations on round geometries. This approach is particularly useful for achieving fine surface finishes on complex curved surfaces that follow a cylindrical axis. We'll explore how to set up and optimize the rotary parallel toolpath to maximize machining efficiency and accuracy, helping you produce high-quality results in your 4-axis operations. The objectives of this lesson is to apply Fusion Multi-Axis tab to apply rotary parallel CAM strategies to machine cylindrical shapes in 4-axis setups, and a model CAM in 5-axis CNC mill applications to industry standards, and apply CAM in 5-axis CNC mill applications to industry standards. There are 3 rotary multi-axis CAM strategies, the first being rotary pocket, the second rotary parallel, and the third rotary contour. They're all found under the multi-axis tab in Fusion. Setup for all the rotary multi-axis CAM strategies are very similar, if not almost the same. They must be aligned with the rotary axis motion of the rotary axis machine. And material removal volume is defined by front and back ends in the geometry tab, and diameters on the radii tab, with the rotary contour and rotary pocket requiring inside and outside diameters to be defined, and for rotary parallel only requiring an outside diameter to be defined. The rotary parallel strategy is a finishing strategy operation that uses continuous 4th axis motion to cut parts. Best results when machining revolved parts with a centerline axis. Generally creates a 360-degree motion, but an angular range can be specified. There are several toolpath style directions. The toolpath style direction to use depends on the model. Toolpath that cuts concentric to the rotational axis may not cut surfaces if the step is smaller than the tool step over distance, as shown in this image on the right. The zone circled with the yellow oval is an area that might not be machined depending on the step over increment. So the line style toolpath travels along the axis of rotation and may yield a better result for this type of step geometry. In some cases, you may actually want to use both and use both strategies to have full cleanup. There are 3 toolpath styles. The first 2 operate concentric to the rotary axis, and the first one is circular. It rotates the part within the tool with the tool at a fixed position and machines cross sections, and before moving to another cross section there's a step over distance shown by the number 1 arrows in the image on the right. The spiral command is similar, but it moves in a continuous spiral cut to machine and starts and ends with a full circle. The spiral style toolpath is suited for simultaneous 4-axis machining, and it generates a continuous toolpath which gives a superior surface finish when compared to circular. An advantage of circular, though, is if you're not doing a full 360-degree turn, it allows you to do a section and say only do 90 degrees, 80 degrees, or whatever parameters set. And then the line style moves the tool along the rotary axis in a 2-axis motion. The rotary axis is then moves in an incremented on a short link pass between step overs. So that's shown by the number 1 in the graphic on the right. Okay, now we're going to go to a demonstration of applying the rotary parallel multi-axis cam strategy in Fusion. Okay, we're going to pick up where we left off with the rotary pocket command, which roughed out the material on this, and we're going to do a demonstration of the rotary parallel command. So we go to multi-axis, and we're going to select rotary parallel. We're going to keep the default tool. It's already in the system. Now parallel has the multi-axis command here, so you can select collision detection avoidance, and it'll, I believe, show you the undercuts. So we could select that. It's going to try to keep the tool holder from running into fixtures. Okay, we're going to go to rotary axes, and I notice that the cylinders it's creating for your part is in the wrong axis because it's defaulting to the rotary axis being set up in line with the z-axis of the machine. In our case, it is not. So we want to set up our rotary axis in orientation to the rotary, which should be what you see here. Okay, and one note, if you are picking up on this tutorial, you may need to reference the rotary pocket tutorial to get this set up for this. So you may need to review the previous tutorial to get your stock size and some of the radial settings correct to get to this point. The file we're using is a tutorial file that is write protected by Fusion. Okay, so we've got our rotary axis. We have our stock front. Make sure that it says front at what would be facing to the left of the machine for this orientation. If this is backwards, you have the lathe axis probably still set up with your stock, and you need to back up to that step. So your front, this is bracketing the area you're going to be machining. So we want to machine between the front and what's set for model back right now. We don't want stock back because that would go inside the chuck. Now you can adjust these, offset these a little bit, and that's one way you can control it from rolling over the edge of the model if you choose to. Or you could hit selection if you had a wall or something you don't want to interfere with. Okay. Okay, so we got, you can set angular limits from different areas. So if you weren't cutting a full 360 degrees, you could just machine within those angular limits. Say you only wanted to machine in this area, I believe you can set an angle of rotation. We're going to go full 360 because we can. And then you can include the model if you like. That's for features that might not be identified automatically by the setup. You can set areas to avoid and put limitations on that. Alright, so I'm going to go to the next tab. We're going to go to radii. They only give you the option to set the outside diameter on this command. So you have to be careful that you don't have it go machine all the way to the minimum. This is partially because I set my stock up as a solid bar. Had I done tube, I could have selected a different area for the minimum area. We're going to leave all this at default. We'll go ahead and go at stock OD just in case for clearances. You could go to model OD, but you know, if there's material that you want to avoid on one end, that's a good thing to do. And then we go to passes. We'll, for demonstration purposes, we'll stick with the 1/8 inch step over so you can see it. If you were doing a finishing pass, a true finishing pass, you'd probably want to do that a little bit tighter. We're going to allow machining in both directions. We're going to go with the default spiral first, and then we'll go through the different options to see how the different options work. And tool offset, you can offset it so that the center of the cutter doesn't actually touch. Okay. And then we're not going to leave any stock to leave. We're going to leave smoothing alone. And let's go to the linking tab. We're going to leave all this at default. Let's hit OK. Takes a little time to process. Okay, so it spirals around. It looks like it's detecting that the ball cutter can't cut in this area, and we're kind of coming up against a wall here. So to truly finish this part out, it looks like you might need to use a little bit smaller diameter cutter or approach it in a different angle. Now let's go back into this command and let's look at some of the other options we have. Under passes, we're going to switch and we're going to go to line and see how that processes the part differently. Is that okay? Okay, so this goes on a different axis. Looks like it's still avoiding the same area here. That could be our collision avoidance. But depending on the geometry of your part, you may want to go in a different direction. So if we were to hide the tool path, this is what our resulting part would look with that setting enabled. We have some little pieces here that are left behind. Let's go back to the collision avoidance and turn that off and see if that changes anything on our geometry. And it did. It cut that area, but you'd also have to make sure that, yes, your tooling parameters are such that you're not having a collision. So some of that is adjusting your tooling models of your tools, and could be also this the smoothing distance. You could set this, right now it's 1.5 inches, which seems actually pretty big. There are other examples are all in millimeters, so that is looking really big. So let's try 0.1. Okay, so with the current model, it thinks it's colliding with the holder. That may or may not be true on your setup. So we will deselect collision avoidance just so that we can. Okay, so now let's go back in and let's look at our third option of tool directions. Yeah, instead of line, let's see what circular does instead of spiral. I suspect it's going to be very similar. And so it just goes around, but then it's going to have a sideways move somewhere in between. So if we rotate around, you see that there's this this line running the length of the part. That'll leave a witness mark there. So that's where it's moving from circle to circle. So I suggest that the best finish on most parts of this command lends itself to just use the default spiral unless you have a reason to go, say, in both directions and repeat the command maybe for roughing purposes. Okay, you can leave stock to leave if you wanted to come back and do this as a remedial roughing cut for another finish cut. Most of your linking tab parameters, it's going to be lead ins, lead outs, things like that, safe distance, how it handles retraction, whether it's at rapid or not. We're just going to go ahead and take that default, hit OK. All right, so let's simulate this so we can see what it does. I'm going to simulate the whole program so that the roughing's going, but I will speed it up for you so you don't have to watch the whole thing again. Okay, so I skipped the roughing, but as you see, it's going around, spinning the part. Somewhat like a phonograph record. Now naturally, if you're doing this as a finish cut, true finish cut, you would want to put significantly closer scallops and perhaps go in with a smaller diameter than what the roughing ball cutter is to give yourself clearance at the end. Yeah, it looks like the holder on this particular model gouges with their example, which is kind of interesting because that was the model that was given with the project. So you gotta make sure you have enough stick out so that doesn't happen. Okay, we're gonna exit simulation. Okay, I hope that demonstration was fruitful for you. Just in summary, in this lesson we dove into the Rotary Parallel CAM strategy in Fusion, and it's a versatile tool used for machining cylindrical parts with precision. The Rotary Parallel strategy generates toolpaths that follow the surface of the workpiece as it rotates, creating smooth, parallel cuts and ideal for finishing operations on round geometries. This approach is particularly useful for achieving fine surface finishes on complex curved surfaces that follow a cylindrical axis. We'll explore how to set up and optimize the rotary toolpath parallel toolpath to maximize machining efficiency, accuracy, and help you produce high quality 4-axis CNC operations. And by the end of this lesson, you should have been able to apply Fusion multi-axis tab to apply the parallel CAM strategy to machine cylindrical shapes in a 4-axis setup. You should CAM model in 5-axis CNC mill applications to industry standards, and you should have applied CAM and 5-axis CNC mill applications to industry standards.